Hello participants, in this video we will discuss the solution to the problem the angry golem. So even though this problem is more of an implementation task rather than an algorithmic thinking or logical task, we will discuss the solution and how we can approach the implementation. So it is mentioned that there are n fortresses lined up. So suppose there are n fortresses and each fortress has some structural integrity, and each fortress has some structural integrity hi. So the structural integrity of the 0th fortress is h0, the structural integrity of the fortress at the first index is h1, then the second fortress, the fortress at the second index is h2, and so on till h minus 1. There is also a golem who attacks these fortresses m times. The golem attacks these fortresses in a way that it will attack the first fortress first, then the last fortress, then the first fortress, then the last fortress, and so on. It will continue this alternatively. And in each attack, when golem attacks this first fortress one time, the structural integrity of that fortress reduces by 1, and when it attacks the last fortress, the structural integrity of the last fortress reduces by 1, and so on. And when the structural integrity of a fortress becomes 0, it collapses or crumbles. Suppose after some attacks, the structural integrity of this particular fortress becomes equal to 0, so it collapses or crumbles. Then we won't consider this fortress again. We will consider from this fortress at the index 1. Now golem performs in this way. So the golem will first attack this fortress, then this fortress, then this fortress, then this fortress, and so on. So the golem will alternatively attack the first and the last fortress, and in each attack the structural integrity of the fortress that it is attacking will reduce by 1. So what we have to find is that after golem attacks m times, after golem attacks the total m times, we want to find out how many fortresses crumble. How many fortresses will crumble after the golem finishes its attacking rampage. So it's actually just mostly an implementation task. You have to cleverly implement it. Like if you implement going first, going last, going first, going last again and again, it would TL because the test cases are last. So you have to put some trick or small amount of logic into it so that implementation becomes optimal. So what we are going to do is that we are going to put 2 pointers. So the first pointer, suppose the I pointer, I will initially give it as index 0, and the second pointer, let's suppose call it the jth pointer, I will give it the index n minus 1. So the I pointer will initially point at the 0th index, and the j pointer will initially point at the n minus 1th index, where n is the number of fortresses given in the problem, right? And now what I will try to do is that I will start attacking from the ith fortress. So when can we entirely attack the ith fortress? So initially the ith fortress is 0, right? So the structural integrity of the ith fortress is h0. When can we be sure that the ith fortress or the 0th fortress collapses or crumbles? For what value of m are we sure that the 0th fortress will surely collapse? Some of you might say, if m greater than or equal to h0, we are sure that the 0th fortress will crumble because we have the number of operations greater than or equal to h0, so it should collapse, right? No, it should not, because like we are alternatively attacking. So even though, so there is h0 over here, so even though m greater than or equal to h0, since after one attack we are attacking at the last, and then we are coming back to the first, then we are attacking at the last. M being greater than or equal to H0 doesn't guarantee that the zeroth fortress will collapse. So the value that ensures that the zeroth fortress will collapse is H0 plus H0 minus 1. If M greater than or equal to H0 plus H0 minus 1, we are sure that the ith fortress or the zeroth fortress will collapse. Why is that? So suppose the structural integrity of the zeroth fortress is equal to 3. Right. Now how many attacks do we require so that it collapses? So initially we attack over here. So the structural integrity now becomes 2. Then we attack at the last. Then we come over here and attack again. Now the structural integrity becomes 1. Then we attack at the last. Now we attack here again. Now the structural integrity becomes 0. So when it became 0, the zeroth fortress collapsed, right? So it required 3 attacks in the front and 2 attacks in the back. So that's why we are writing here H0 plus H0 minus 1. H0 minus 1 in this case is 2. That's what we got over here as well. So if M greater than or equal to H0 plus H0 minus 1, we are sure to collapse the ith fortress or the zeroth fortress in this case. And we can increment I plus plus. We can move the pointer to the next index. And we can subtract these number of attacks from M. But these amount of attacks are performed at the last fortress or the few fortresses in the last, right? So we have to go ahead and perform that. We will do a for loop and we will perform these amount of operations in the last fortress or the last few fortresses, and we will decrement J according to whether a fortress will collapse or not. Alright. Now, what about the case where M less than HI, M less than HI plus HI minus 1? So in this case, we are sure that we will not be able to collapse the ith fortress or the first fortress. Alright. But it may be possible that we can collapse a few fortresses or the last fortress at the end. Right. So now we have to find how many attacks will be performed on the last fortress or the few fortresses at the last. So the number of operations that we are going to perform at the last fortress will be equal to the number of attacks that we perform on the last fortresses will be equal to M by 2. Because why M by 2? Where did the other M by 2 go? Even though we can't collapse the ith fortress, we have to perform the operations on the ith fortress, right? Like, it doesn't matter whether we can collapse the ith fortress or not, but we have to go alternatively. So we have to perform an operation or attack on the ith fortress, then only we can go to the last fortress. So the other M by 2 attacks will be performed on the ith fortress, and these M by 2 operations will be performed on the j fortresses on the jth fortress at the last. So now we have to implement this. So implementation is the main task. This is the main logic. Like the only logic was understanding this equation, and these two are the if statements. This is the first if statement and this is the else statement. So I will show you the implementation now. Now we will discuss the implementation for the problem, the angry golem. So initially we are inputting P, which is the number of test cases, and we are inputting N and M, where N is the number of fortresses, M is the number of attacks the golem has, and vector of h will store the structural integrity of each of the fortress. And now we have defined two pointers. The initial pointer points to the first fortress, and the jth pointer will point to the n minus 1th pointer, n minus 1th fortress. And inside this count variable we will count the number of fortresses that was collapsed or crumbled. Now we will run a for loop while we have attacks left and I lesser than or equal to j. If I not lesser than or equal to j, it means that there are no more fortresses to crumble. That's why we are checking whether I less than or equal to j. And now, as we have discussed in the explanation, we will check for the first condition whether m greater than or equal to h of I plus h of I minus 1. If it's the case, we can crumble the ith fortress and we will subtract h of I from m, since h of I will be the number of attacks required to crumble the ith fortress. We will subtract h of I from m and we will increment count by 1, because we have collapsed one fortress, the ith fortress, and the attacks left is this the remaining factor. So we have used the first factor to collapse the ith fortress. Now this remaining factor will be used to collapse the fortresses at the back. So attacks left is h of I minus 1, and since we have collapsed the ith fortress, we will increment I. Now I will so now we will using the attacks left, we will collapse the fortresses at the back. If attacks left greater than or equal to h of j, we know that we can collapse the jth fortress. So we will decrement h of j from attacks left and we will increment the count. Since we have collapsed or crumbled one more fortress, we will increment the count and we will decrement j, because we have collapsed the jth fortress, so we don't need to consider it anymore. So we are decrementing j. Else, in the else condition, if attacks left not greater than or equal to h of j, what we are going to do is that we are going to just subtract this attacks left from h of j. Since attacks left not greater than or equal to h of j, this after subtracting also h of j will be greater than 0. So we don't increment j in this case and we don't increment count in this case, because h of j has not yet become equal to 0. So it has not become crumbled or collapsed. And since we have used the entirety of attacks left, we will put attacks left as 0. Now in the else statement, is the condition where this doesn't satisfy. In the else statement, what we are going to do is that we know that we cannot crumble the ith fortress. So the attacks that we have left is m by 2. We will use this m by 2 attacks to crumble the fortresses from the back, and we will apply these many operations on the ith fortress m minus m by 2 on the ith fortress. Why are we writing m minus m by 2 and not directly m by 2? Because you may ask, m minus m by 2 is equal to m by 2, right? M minus m by 2 will be equal to m by 2 in case of even m, but in case of odd m, that may not be the case. In case of odd m, this may be this will be larger than m by 2 by one value. And now we will put m is equal to 0, because we have used all our attacks. We have used up all our attacks. Now we will start attacking from the back while we have some attacks left. This simply means that this is the simplified version. This actually means attacks left greater than 0. I didn't write greater than 0 over here. It's fine. You can it's fine in C++. It actually means attacks left greater than 0. So we will do the same thing that we did in the first condition. If attacks left greater than h of j, we will subtract h of j from attacks left, and we will increment count, and we will decrement j. Otherwise we will just decrement attacks left from h of j, and we will put attacks left as 0, and we will output the count at the last. So this is the implementation for the problem. Hope you have enjoyed the problem. Thank you.